Okay, we're going to wrap up section 8.1 in this video. What we had done in the last video is evaluated formulas. Okay, we were given all but one of the letters, they stand for real numbers. We were given those numbers, we put it in, and we crunched out a value for the remaining unknown, the only unknown in the problem. Okay, well, sometimes the equation was set up properly for us, and sometimes it wasn't. Okay, and by properly I mean we had the unknown letter equals everything else, and we just put it in there. You saw we had one example where we had to kind of do some algebra, so to speak, shuffling things around, but we had good old numbers to shuffle. We were familiar with that. Well, now we're going to do it with letters instead of numbers, okay? But it's the same thing. So let me first just throw exactly what I'm about to do with the letters here, but I'm going to do it with numbers here. Let me just say 12 equals S minus 4. Okay, piece of cake equation, right? Solve for S. How hard can that be? Add 4 to both sides, add 4 to both sides, and right there we're done. S equals 16. Okay? We're going to do the same thing except letters. Okay, we're going to have some formula. Okay, and again, we'll talk about what the formulas are. This is the formula for to mark something up. Retail markup. Well, you've got your sale price minus your cost. The retailers pay a certain cost. They mark it up and they sell it to us for the sale price. Well, how much is that markup? You take the actual sale price minus the cost they pay, and that's the amount of the markup, okay? Well, we're going to be asked to solve, in this case, for S, okay? It's currently solved for M, meaning M equals all the other stuff. Well, now I want to turn it around. I want S to be equal all the other stuff. It's exactly what I did here with the numbers. You see, it's exactly the same. How am I going to do it? Well, I added 4 to both sides, so now I'm going to add C to both sides. Go on over here, add C, okay? But here's the difference. I could put the 12 and the 4 together to get a 16, but over here I can't put the M and the C together because I don't know what they are. So I just have to leave it as M plus C. So it looks a little different. But otherwise it's exactly the same thing we just did. M plus C equals S. We have solved for S. Typically we put the unknown on the left, so I'll just turn it around. And there we go. S equals M plus C. Okay, we have shuffled this formula around and we have solved it for a variable other than the one that was already there. Okay, that's all we're going to do in this next few examples. Okay, let's look at that same formula. This time, let's solve for C. Okay, this is actually example 7 on page 381. Okay. Solve for C. Get C all by itself. So we say, okay, let's subtract the S away. Subtract the S away, so I've now got M minus S equals negative C. Okay, we gotta be a little careful now. Okay, I need C, not negative C. But what does negative C mean? It really means I've got a coefficient of negative 1 C. So I need to divide by negative 1. Divide everybody over here by negative 1. Okay? Well, I can think of it like this if it helps me. I've got M divided by negative 1 minus S divided by negative 1 equals C. Okay, we just got to be careful here. And M divided by negative 1, that just makes it a negative M. Okay, now we just kind of watch out. If I want to call that a subtraction sign and I want to bring it down here, well, now it's gone. So now S divided by negative 1 makes that a negative S, right? Equals C. See that? Negative plus negative is going to be positive, so it's really negative M plus S equals C. Okay, is everybody cool on that? Now you may have done this in one step. You may have thought of that as a negative S divided by a negative 1 and turned it into a positive S. That's what I would have done, kind of on my own. I'm trying to really walk us through the steps here. Okay, so far so good. And then it might just be, so we can turn it around, right? I'll turn it around here and I'll say C equals negative M plus S. Okay, and then even a little cleaner way to say that, would be C equals S minus M. I'm just going to reverse these two positions, right? And I can do that. As long as the negative stays with the M, which it did, because it's now minus M, that would be really the cleanest way to show the formula. Instead of having a negative M, I'll just call it S minus M. Okay, so we shuffled around. That's all we're doing. Shuffle, shuffle. All right, let's check out example 8. Good old I equals PRT. We've seen that formula a few times. Interest equals principal times rate times time. However, let's say I know the interest, I know the principal, and I know the time. I don't know the rate. I want to solve for R. Solve for R. Think about it. Think about it. What's the relationship between P, R, and T? They're all multiplied together, right? They're all multiplied together. Well, when I multiply numbers together, the order's not important. Agree? So if it makes me feel better, I can put the P and the T kind of together in front of the R. All agree with that maneuver? I just switched positions of the R and the T. So now this PT is like the coefficient in front of my R, right? Divide by the coefficient. Divide by PT. Go on over there. Divide by PT over there. So now I've got I divided by PT equals R. That's what I want. I'll just turn it around to make my unknown on the left. R equals I over PT. Okay, just that easy. If the numbers were there, it would be super easy. Okay, when leaving the letters in place makes it seem a little more difficult, but it's the same algebra we're doing. It really is. There's nothing different whatsoever. Okay? Alright. Example 9 talks about formula for a compound amount. Again, we're not so concerned about what these formulas are. We're just shuffling them around. So I've got some A equals P parentheses 1 plus Ni. Okay, there's my formula. A equals P parentheses 1 plus Ni. And we want to solve this for N. We want to solve for N. Alright, that's a little bit trickier, right? Well, let's think about what we can do. We can distribute our P across, right? So I can say A equals P times 1 is still a P, plus P times N times I would be P N I. So far, so good? Subtract P now, right? Because it's P plus, I'm interested in N, it's P plus something times N, so I'm going to get that out of there. Subtract the P, subtract the P. A minus P equals P N I. Okay, what am I going to do now? I want N. P and I are multiplied by N. Now in the previous example, we went through the motions of actually shuffling it just to put the P and the T side by side. You could do the same thing here with the P and the I, but you don't have to. You just have to recognize we're multiplying by P, we're multiplying by I, so I'm going to divide by both of those things. And they're going to cancel away. And the only thing left is going to be N, 1N, which is what I want, 1N. Over here, divided by P, divided by I. Okay, so my formula, A minus P over PI, that's what N equals. Okay, and again, typically we'll put the unknown on the left, so I'm just going to turn the whole thing around, and we'll show it like that. Alright, all good? It's really just that easy. One more example here in this section, and then all of a sudden we're done with another section. Okay? The formula for power circuits again, single-phase circuits. Voltage equals power over current. Current is usually measured by I, the letter I, voltage V, and I think we had a different letter for power in another example. Maybe I'm wrong about that. P is what I would usually use for power. The formula V equals P over I represents the relationship among the voltage drop V, the electrical power P, and the current I. Arrange these formulas to solve for P. Solve for p. I want p equals, not v equals. Well, what do I have here? I really have a coefficient of 1 over I times p, don't I? That's just a different way to write it. It's a fractional coefficient of 1 over I times p. How do I undo that? I multiply by the reciprocal. So I'll multiply by I over 1 on both sides. Okay, the denominator on the left isn't really accomplishing anything, but over here on the right I've got 1 over I times I over 1. They cancel away and I'm just left with p. On the right, again, my denominators are all 1 here, so I don't really have a denominator. I don't have to think of it as a rational number. I'll just say I times v equals p, and then I'll turn it around and say p equals I times v. Okay? Now you might have said v times I, right? And that's the same, of course, right? Order's not important, so either one of those would be perfectly acceptable. All right, there we go. Shuffling formulas around. Okay? I always like to throw this one in. MA plus TH equals FUN. And that almost looks like it says math equals fun, doesn't it? It sure does. Let's solve for, I don't know, H. Solve for H. How am I going to do it? It's T times H plus this MA equals FUN. So I'm going to subtract away the MA. Subtract away the MA. That leaves me with T times H equals FUN. Those are just three things multiplied together. I don't know what they are. I don't care what they are. Subtract MA. I'm solving for H, so that means T is a coefficient in front of my H. Divide by T. Goodbye. Divide everybody over here by T. So H equals FUN minus MA, all divided by T. Okay, and that's how we do it. Formula shuffling. It looks harder because you've got all the alphabet soup there, but if it had letters in it, you would, if it had numbers, you would zippity-zap your way right through it, no problem. You just have to get accustomed to having the letters there. We're not asked to do anything more than rearrange them. If we were asked to evaluate like this last one, somebody would have to tell me what is F, what is U, what is N, what is M, what is A, and what is T. Somebody would have to give me all that information in order for me to just say H equals some number. All these problems, same way. In order to find P, somebody has to tell me I and V. They're two numbers. I need to know those numbers. Once I know them, I can find P. Okay, same thing with all these. Somebody would have to tell me I, P, and T in order to find R. Somebody would have to tell me A, P, and I in order to really evaluate that and find N. Okay? It's an exercise in shuffling equations around. We're not evaluating these last few. Okay, the very last part of it, section 8.1, starts talking about spreadsheets. Spreadsheets are great, you know, for Excel being kind of the most common one probably. Microsoft Excel. You can put formulas in a spreadsheet and work wonders with it. Okay, we're not going to spend the time in our class to do that, but if you ever work with spreadsheets, they can really help out with calculations and things by putting formulas in the spreadsheets. So thumb through it. It's just a really, really, really basic introduction. There's so much more you can do with a spreadsheet than what's covered in these couple pages. Alright, that ends section 8.1, so our next video will dive into 8.2, which talks about proportions.